Welcome to this demo of my deep learning project, Advancing Precision Oncology, a deep learning framework for predicting drug sensitivity. In this video, I'll walk you through the project's motivation, showing you how to run it and demonstrate the Gradio Web App in action. I'll also guide you through the codebase available on GitHub. First, some background. Drug response prediction is a key step in drug discovery. Understanding drug gene interactions help us in identifying effective treatments and reducing adverse effects. This project predicts drug response using deep learning by combining drug smiles based molecular graphs and cancer cell gene expression profiles. The model uses a hybrid GCN-CNN architecture with cross attention fusion to predict LNIC50 values, indicating drug sensitivity. This is the Gradio Web App interface. Select a drug and cancer cell line from the drop-downs. This is the drug. This is the cancer cell line. You can select any combination from this drop-down. For example, I select this drug and this cell line. Once selected, the app predicts the ln IC50 value and shows a response label that is strong, moderate, or weak. All predictions are based on the deep learning model trained on GDSC and CCLE data. You can try for different combinations. Here we go. Now, coming to the code walkthrough, this notebook handles pre-processing smiles using RDKit, normalizing gene expression data, and creating PyTorch geometric data objects. Also, defining and training the GCN-CNN model with attention. So, this is the first part of our code, which involves pre-processing and training. I'll briefly walk you through the code. We are installing the necessary dependencies. We are performing data preparation. This involves retrieving and organizing the data, extracting the features, the drug molecular features, gene expression features, then merging drug and gene expression data, doing the missing data check, outlier detection in the target variable, which is IC50, splitting into train, validation, and test set, which is 80 is to 10 is to 10, and finally storing our dataset partitions. Here is the code for the same. We also perform EDA on training data. evaluating the different types of drugs and their efficacy levels, defining the deep learning model. Our model architecture comprises of the following. We are also performing hyperparameter tuning. This is our model architecture. Then we train the model and also do hyperparameter tuning. For hyperparameter tuning, we have chosen the following optimizers, the following loss functions, and experimented with these two learning rates. We have experimented with a total of 24 combinations, model combinations in the hyperparameter tuning. These are the result of the top 10 uh, best performing combinations based on the MSE. Since we are doing a regression based problem, we are focusing on evaluation metrics like mean squared error, Pearson's coefficient, Spearman coefficient. So after doing the hyperparameter tuning, this is the best configuration we have achieved. This is the code for training and the hyperparameter tuning. We have also generated train, test, loss graphs, which help us to evaluate the model performance during hyperparameter tuning. So this is the hyperparameter tuning logs. After doing the hyperparameter tuning, we have saved all the models and the corresponding results in CSV files. Also, we have generated CSV and JSON files for our Gradio DrugResponse app, which will be used later. Now coming to the second part of the code, which is the testing and deployment code. So this notebook handles model testing and metrics, uh, prepares drop-down data files for our Gradio app. Sorry, which it is done. This was done in the previous part. This is just loading those files, and this is launching the Gradio app locally as well. So you can launch the Gradio app in two ways. Either you can do it through this collab notebook, or you can also do it locally via your bash or terminal. So let's walk through this notebook first and discuss the testing and the deployment part. So this notebook, first of all, we are loading the test data set. This test data set was separated from the train data set, and this is a holdout test set. Now we are loading the saved model from the training phase. We define the prediction and evaluation functions here, which evaluate the model based on root mean squared error, Pearson's coefficient, and Spearman's coefficient. We also plot a histogram of residuals plot. So this is how the model uh, performs on the test data set. These are the values of the metrics. Then we have the residual plot. After that, we do the per drug evaluation. This is the per drug evaluation, the top 15 drugs with the lowest mean squared error. After that, we perform model deployment using the Gradio interface. So this function is the predict function for the dropdowns. And this is how a Gradio web app is deployed. Now coming to the next part, which is running the Gradio web app locally. Apart from running the web app through this Jupyter notebook or Colab notebook, you can also do it locally. So these are the setup instructions for running the web application locally. To run the project, you can clone my Git repo, install the dependencies, and then run the web app. This is how the web app looks after running it. Now talking about the data sources, the IC50 and the gene expression data come from the GDSC and the CCLE data sets, which are available online. The links to the full data, raw data, and the pre-processed test data are available in the README file on the GitHub repository. So thank you for watching. To try the app or explore the code, you can visit my GitHub repository and feel free to star the repo and share your thoughts. See you next time.